Okay, so this is our review for test number 3, which covers the first 4 sections of chapter 6 plus completing the square and ellipses. So there are 10 problems on the test. It took me 24 minutes, which means it's probably going to take you at least an hour and 15 minutes to do it if you are normal. If you're sharp, you may finish it in an hour or less. So just plan on having enough time to devote to the test. So there's going to be 3 law of sine, law of cosine problems. So there'll be 2 triangle problems, and there'll be, well, all 3 triangle problems, of course, but one will be an application. So we have the law of sines. And that says that the sine of angle A divided by the length of side A is equal to the sine of angle B divided by the length of side B times the sine of angle C divided by the length of side C. So you can see you need at least, well, if you have a matching angle and side plus either a second side length or angle, you can solve for it. If I gave you 2 angles, you could find the third angle not by using the law of sines, but just by using the fact that the sum of the angles in a triangle add up to 180. So the first problem, just so there's no confusion, is a law of sines problems. So you don't use the law of cosines at all, but you do use the fact that angle A plus angle B plus angle C is equal to 180. So if you're given 2 angles, then you can immediately calculate the third angle. So you can see in this law of sines, I can give you 2 angles and one side, one of the corresponding sides, or if I give you 2 angles, you may need to use this relationship, the sum of the angles equals 180, to get the third angle, and then you definitely will have, you know, like if I gave you angle A and angle B, but side C, you might like, well, I've got one from each of them, so what do I do? Well, what you could do is find angle C first, and then you'd have a matching letters of angles and sides. So you want to make sure you know how to label them. I ask you to label them. So, you know, the angle is capital letters and the side length is small letters, and the side letter is opposite the angle letter. So this is angle A, side A, angle B, side B, angle C, side C. Just got to be careful with C's because they both look the same, you know, in terms of capitalization. When it comes to A and B, it's pretty straightforward which one is lowercase and which one is uppercase. Now, there are all those complicated situations as far as whether, you know, whether there's 2 solutions, 1 solution, 0 solutions, etc. And I'm not going to test you on that particular thing just because there's a lot of different things you have to worry about. And if you go on and you use the law of sines, you can become more familiar with that. But I'm going to have mercy on you on that concern. So let's say, let me just give you a couple of examples here. I'm not going to work through them, but just going to give you the idea of if you're given something. So let's say you're given angle A, and you're given side A, and you're given angle B. Well, first thing you could do, if I'm given 2 angles, I could find angle C right away. It's going to be 180 minus A minus B. And then you could find, say, side B. We know angle A and side C, so you could solve for side B using these two things, and if you do that, you get B is equal to A times the sine of angle B over the sine of angle A. Make sure you understand how I get these things, because I don't want you to just copy these down and say, oh, if I copy these formulas, I'll be able to do the problem. That's not the point. And then you could find side C by taking the length of side A, and you found angle C by doing that. So then you could find side C using law of sines. So if you're given two angles and a side, calculate the third angle and then use the law of sines. Now the other situation is if I gave you A, small a, the side length, and B. Well, there I only know one angle, so I'm going to need to know another angle somehow or another. So what you would do is you could find the sine of B, because that corresponds to this one, is going to be equal to the sine of A, which I'm given, times the length of B over the length of A. So from that I could find B, of course. B is the inverse sine of D sine. So I use what I got in this previous step. So that gives me angle B. Then once you've got angle B, you could find angle C, 180 minus A minus B. And then finally, the only other thing I don't know here is side C. And for that, you'd have to use the law of sines, which I've already written it down over here in the previous scenario. So you have A times the sine of C over the sine of A. Okay. The other, I guess really the only third option is if you were given, let's say you were given angle A, angle B, but side C. So you can see these previous ones, I've given two angles, AAB, here I got AAB. Here I give you angle B, here I give you side B. Now, if I give you two angles on the third side, the difference here is you would first find side C, which would be 180 minus A minus B. And then once you have angle C, then you could say find side A, and I've got angle C and side C now, so so I'd say is it's length of side C times the sine of A over the sine of B, over sine of C. And once you had A, you can find B. Again, you know C, so just use C times the sine of B divided by the sine of C. So you're given these three, you calculate the angle first, then the two sides. Here we calculate the angle first, the second angle first, then the third angle, and then the third side. In this case, we calculate angles. I'm given two angles, so I can figure out angle C immediately, and then I could use the law of sines. Okay, so just review law of sine problems. Law of cosines. Now that depends upon which ones you're given. Now I purposely didn't label them so you could label them. I'll give you, now for the law of cosines, typically what you're given is, let's say this is angle A and this is side A, so we can call this angle B, side B, angle C, side C. So typically you are given either all three sides, and then you can calculate the angles. I mean, yeah, if you're given all three sides, you can calculate the angle. So for example, the cosine of A, if I'm given A, B, and C sides, it's going to be cosine of A is equal to B squared plus C squared minus A squared. We always subtract the side associated with the angle, and then divide by 2 times B times C. So it's the two angles that are not involved. So the only place A shows up is this subtraction, and the rest of them are the other angles. So once you find A would be the inverse cosine of the cosine of A. So that would give you angle A. So here I'm given, now once I have three sides and one angle, you can use law of sines to find either angle B or C. So we use the law of cosines to find one angle. We find the second angle using the law of sines, and then once you have two angles, then you can use, let's say I choose B, find B, then angle C. Once I find B, then angle C is just 180 minus A minus B. So in this law of cosines thing is I use the first step to find either the angle, which I don't know in this case, and then the second step, always you can use the law of sines, and the third step you can use the sum of the angles in a triangle equals 180. Now if you let's say here this was given A, side B, and side C. Let's say in the other option I'd be given B, C, and angle A. So here's A, here's B, and C. So it's side, angle, side. So in that scenario, what you do first is you find side A length. And the equation for that is A squared is equal to B squared plus C squared minus 2BC times the cosine of angle A. So you can take, of course, A is the square root of A squared, whatever I get in this previous step. And at that point, I have three sides and an angle. So again, the second step would be to, once I have A, I could find, say, side, then I'll deal with the angle B. Okay, so what is that? Well, we know the sine of B, and now that I have side A and I have angle A, I can say sine of B is equal to the sine of A times B over A. So I'm given B, I've calculated A, I've been given angle A, so then I can find angle B by taking the inverse sine of the sine, and then angle C, which I don't know yet, is 180 minus A minus B. So you can see this, if you're given three sides, use the law of cosines to find one of the angles. Once you have one of the angles, use the law of sines to find a second angle. Once you have the first and second angles, you can calculate the third angle. Here, you're given two sides and the angle between them. So first you use the law of cosines to find the other side. Once you have three sides at an angle, then you can find the second angle using the law of sines. And once you have two angles, you can find the third angle by subtracting the other two angles from 180. Now, the problem, the what do you want to call it? The application. Of course, I can't tell you what it is, but you actually have to use a little bit more than just the fact that you have a triangle, and you can use either law of sines or cosines. I'm not going to tell you which one it is, but I'm just going to give you this as a hint. So if you have two parallel lines and a transversal connecting these two, then this angle, we'll call it theta, is the same as that angle. So you may need to use that in addition to the stuff to do with triangles. The other thing too is if you are given, let's say you're given this angle, let's say that's 12 degrees, and you're given that the total angle here, like that, from this horizontal line to this second line is 20 degrees, then the angle between these two is just 8 degrees. You know, the angle's 8 plus 12 has to equal 20. And you also need to know how to use, in addition to the law of sines, you'll need to know, that the sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse, and the tangent of theta is equal to opposite over adjacent. Okay, so there's a right triangle involved in that. Okay, then you've got some vector problems. So one problem is just I give you two vectors. And it just asks you to do some vector operations, addition and subtraction. So, let's say I asked you to add the two vectors together. So all you do is you add the components. So you get 1, 2 minus 1 is 1, negative 3 plus 2 is negative 1. So that would be them added together. If you took u minus v, that's the same as u plus negative v. So in our case, you'd have 2 comma 3 vector plus, and then I'd take the inverse of those, so that become 1, negative 2. Just change the sign of the 2. And then I'd add them together. 2 plus 1 is 3, so it would be 3. Negative 3 plus negative 2 is negative 5. So that would be u minus v. And then I might do something like 3u plus v. So there you take vector u and multiply it by 3, and then add it to vector v. So I'd go ahead and multiply this by both of the elements. So you get 6 comma negative 9 plus negative 1 comma 2. And if you add those two together, you get 6 plus negative 1, which is 5, and negative 9 plus 2, which is negative 7. Okay, so that's pretty straightforward. Now this is the coordinate pair representation of vectors. Let's say I gave you a vector u, which is 7 comma negative 1, and I ask you to rewrite it in unit vector notation. What does that mean? So you'd say u is 7i minus 1j. So that's the unit vector notation. Now the x component, so we call that u sub x. We take the vector part off. We just call it u sub x is just this number 7, and u sub y is negative 1. So this is the x component. This one would be the y component of the vector. So here you look at this vector. 7 is the x component, negative 1 is the y component. Okay, next thing is I'm going to give you a vector, and let's say it's negative 1 comma 5. And what I want you to do is give me the magnitude and direction. So I could plot this point, negative 1, 5, right? So negative 1 in the x direction. And this vector is represented by a line with an arrow from the origin to that point. And the angle that it makes is this one. So this is theta, the angle. So the question is, how do you figure out what that angle is? Well, you use some geometry. You know, it's in the second quadrant. And so what we could do is we could find the reference angle associated with this point. And because we're given x and y, we probably should use the tangent. So what we'd say is the angle theta, or the reference angle associated with that, would be the inverse tangent of the absolute value of 5 over negative 1. Now in this case, I'm using degrees. Vectors, we use degrees. So you take the inverse tangent of 5, because negative 1 absolute value is that. So you get 78.7 degrees. And in the second quadrant, theta is equal to pi minus the reference angle, or pi, but in this case we want to use 180. We haven't done that much, but 180 minus 78.7. So that's the second quadrant solution. And we know that because we plotted the points. So we'd get the theta, which is the direction, is that. This is the direction. Now the magnitude, all you have to do is the magnitude of vector v is equal to the square root of the x component squared plus the y component squared. So our x component is negative 1, our y component is 5, so you get the square root of 26, 25 plus 1, and that's your answer. So you got to use a little geometry to figure out this angle, especially if it's not in the first quadrant. So plot the point that represents the vector, see what quadrant you're in, use the appropriate formula for the quadrant. Okay, now next thing is finding a unit vector. So let's say we have vector v, and it's equal to negative 2 comma negative 7. So how do you find the unit vector? Well, the unit vector is just equal to the vector of interest divided by the magnitude of the vector. So the magnitude, we just talked about that right over here. The magnitude of the vector is the square root of the x component squared plus the y component squared. It's always a positive number. So we get 49 plus 4. So you get the square root of 53. So the unit vector is going to be equal to 1 over the square root of 53. So that's 1 over the magnitude times vector v. And typically we'll go ahead and multiply this out. So we'll just move that inside. So it's negative 2 divided by the square root of 53, comma, negative 7 divided by the square root of 53. And then we can rationalize it. So we'd get negative 2 times the square root of 53 divided by 53, and negative 7 square root of 53 divided by 53. And what the unit vector is, it's a vector that is in the same direction as v, but has a length of 1. Okay, continuing on in vectors, finding the angle between two vectors. So to find the angle, you find the cosine of the angle. So remember, the cosine of theta, this is the angle between vectors, is equal to the dot product of the two vectors divided by the magnitude of u times the magnitude of v. So these are all scalars. So that gives you the cosine of theta, and then theta is going to be the inverse cosine of the cosine of theta, the thing you get from the previous step. So let's look at two vectors. Let's say u is 6, 1, and v is negative 7, 2. If we draw this vector, you're going to have u is going to look something like this, and v is going to look something like that. So we'd expect the angle to be greater than 90 degrees. So let's plug in the numbers. Let's get the different quantities and then plug them in. So u dot v, so we take 6 times negative 7, which is negative 42. 1 times 2, which is 2. So the answer is 40, negative 40, which immediately tells me that the angle is between 90 and 180 degrees. The magnitude of u is equal to the square root of 6 squared plus 1 squared, which is the square root of 37. The magnitude of v is equal to the square root of negative 7 quantity squared. So don't take negative 7 squared. It's negative 7 the whole thing squared, because you'd end up with a negative square root, which you can't do. Okay, here we have 49 plus 4. So that's the square root of 53. So let's go ahead and plug it into the formula here. Cosine of theta is negative 40 divided by the square root of 37 and the square root of 53. And this number has to be between negative 1 and positive 1, or you've made a mistake. So you get negative 40 divided by the square root of 37 divided by the square root of 53, and I get negative 0.9033. And then you take the inverse cosine of that number, making sure that your calculator is in degrees, and I get 154.6 degrees, which is what I thought it was going to be. Pretty big, because this vector's hugging the x-axis close, and this one's hugging the negative x-axis close. Okay, so that's finding the angle between two vectors. The next thing is finding the projection of one vector in the direction of another vector. So it looks very similar as far as the equation, and we write this as the projection of vector u in the direction of vector v. So the subscript tells you which direction we're going. And what you do is you take u dot v, so these are two vectors, that's u, not n. And instead of dividing by the magnitude of u times the magnitude of v, you divide by the magnitude of v squared. So this is a scalar and this is a scalar, meaning a number, and then you multiply by vector v, which is a vector. So this gives you a scalar times a vector. Okay, so I'm going to make up one here, so make sure this. So let's say we have um, here's vector u, and here's vector v. So I'm going to make vector v longer. So let's think about what this might be. Let's see, this is vector u is 4, 5, and we'll let vector v be 8, 2. So you can see it goes much further in the x direction than the y direction. And physically what's going to happen is this is the projection of vector u in the direction of vector v. You have this right angle. So you can see the projection is the same direction as vector v, but it's shorter, and it's shorter such that you create a right angle between this projection and the other vector. This second vector, when added together, give you the original vector. Okay, so the projection of u in the direction of v, what do we need for that? We need u dot v. So that's u is 4, 5 dotted with 8, 2. So you have 8 times 4, which is 32, plus 5 times 2, which is 10, which is 42. Okay, so that's the numerator, 42. And you know, because this projection is shorter than vector v, I should get this fraction should be less than 1, because what I'm doing is trying to shorten this vector v. Okay, so the magnitude of vector v squared, you just take the components and square them. 8 squared plus 2 squared, so that's 64 plus 4, that's 68. So that's 68. Now the magnitude is this square root of this, but if it's the magnitude squared, you just add the squares of the components. And you can see this number is less than 1. And then you multiply that by vector v. And I want you to go ahead and multiply this out. Do it as a fraction. So you might be able to simplify this, but let's just multiply it out first, and then we'll simplify it once we get it inside the vector. So 42 times 8 is 336 over 68. And then you get 2 times 42, which is 84. 2 times that divided by 68. So we just need to simplify these fractions. So what I do usually is I take them and I keep dividing by 2 until I can't divide by 2 anymore. So 336 divided by 2 is 168, and 68 divided by 2 is 34. They're both still even, so we can do it again. 168 divided by 2 is 84 over 17. Unless you can divide 84 by 17, then we can't go any further. So this becomes 84 17ths. And here we have 84 over 68. So if you divide both those by 2, you get 42 over 34. Do it again, you get 21 over 17. 21 over 17. So that's the final answer. So make sure you simplify any fractions that you end up with. Now I'm not going to ask you for what this other vector is, but the way you would get that is take vector u and subtract this vector, and that would give you that vector. Okay, now moving on to completing the square. I'm just going to give you a simple completing the square, but you will have to factor something out here. So let's say we have 6x squared plus 36x minus 12 equals 0. So this is just to show you know how to do completing the square if you don't know how to do ellipses. So if we factor the 6 out of the x squared and out of the 36, we'll get that. Put a little space there. Yeah, go ahead and move the constant to the other side. So that negative 12 becomes positive 12. And then we take the coefficient in front of x, divide it by 2. Simplify it, square it, you get 9. So we add 9. So we have 9 times 6. 9 times 6 is 54. So we're adding 54. So we can add 54 to the other side. And then you can replace this polynomial with a complete square, which is x, go to this number, plus 3 squared is equal to, and then add these two numbers together, which is 66. And that's what I'm looking for, just at that point. Okay, the last problem, I'm going to give you an ellipse, but it's not in standard form. So you're going to have to convert it to standard form. You're going to need to plot it, and then you're going to need to define the coordinates of the vertices and the foci and the center. Okay, so here it is. Hopefully I got this right. We'll find out sooner. So we group the two x terms together, and we group the two y terms together. And we move the constant to the other side and change the sign. Then we factor out the coefficient that's in front of the x terms. So 4 divided by 4 is 1. 8 divided by 4 is 2. Leave a space. Factor out the 25, which is in front of the y squared. So you get y squared. 150 divided by 25 is 6. So you get negative 6y. Leave a space. And write the right-hand side down. Take the middle term, divide by 2. Simplify it if you can, which is 1, squared, which is 1. So we add 1. But we're really adding 4 times 1. So we add 4 to the other side. Here, take coefficient inside, negative 6, divide by 2. Square it, simplify it, negative 3 squared. That's 9, so we add 9. But we're really adding 9 times 25, which is going to be 225. 8 times 25 is 200, and then you have one more. So we're adding 225, so we add 225. So then we rewrite this as a complete square. So it's x plus 1 squared. Here, write this as a complete square, y minus 3 squared. Add the numbers up on the right-hand side. Hopefully they come out to something that I like. 225 plus 4 minus 129. That's 100. Yeah, that's what I was looking for. Okay, we're almost there. Divide both sides by 100. So that means dividing every term by 100. So the right-hand side becomes 1. That's what we want. Here we have 100 divided by 4. So we take this and move it to the denominator of the denominator. Same thing for the next one. So we have 100 divided by 25. And if you can simplify those, go ahead and do it. The one that I have for the test, I think you can simplify it. 100 divided by 4 is 25. Complete square, just see, that's what I was hoping to get. And then 100 divided by 25 is 4. That equals 1. So there we are in standard form. So what can we say? Well, we can say A is 5, because that's this. It's a larger one of the two. B is the other one. Square root of 4 is 2. C squared is equal to 25 minus 4, 21. So C square root of 21. So you know there's usually one that's going to be a square root at least, except for like a 3, 4, 5 situation. But you know, so many times you can do that before you get a little bored. This is 4.6. So we're going to go ahead and plot them before we come up with the coordinates. We'll use the graph to help us figure out the coordinates of all these things. We already have the coordinates of the center. That's easy to do. So the center is -1, 3. So that comes from here, x minus h. So it's -1, x minus a -1, y minus k. So the center is -1, 3. Right there. Now, because this is a larger one, the major axis is in the x direction. So we're going to start at the center and go 5 units. 1, 2, 3, 4, 5 here. 1, 2, 3, 4, 5 there. So those are the vertices. Now the other one is the minor axis. Half the minor axis length is 2, so we go up 2, down 2. The center is right in the center of that. And then the foci are inside the vertices. So we go 1, 2, 3, 4, 4.6 is right there. 4.6 that way. So in this case, the focal points are inside the box. For hyperbola, they're outside the box. And we really don't use the focal points to help us draw this thing. So from that we can draw our curve. So we come like this, go through that point, come over, loop around through that vertex. Same thing here. Same thing there. So just make sure they go through these 4 points and they have some curvature to them. Don't just draw straight lines. Now, to figure out the coordinates, let me just write the numbers up here. Let me write them down here. A equals 5, B equals 2, C equals 4.6. Okay. So let's rewrite the center down. So that was -1, 3. And notice that because the major axis is the x direction, these all should have the same y value. So when you look at the vertices and the foci, you're going to have the same y value, 3, 3, 3, 3. And you can see that from the graph. This is your major axis. See, everything is on this line, y equals 3. Now the center is at -1, so the vertices we want 1, 2, 3, 4, 5. So if you go -1, -2, -3, -4, -5, -6. So that goes from -6. And then you go the other direction, so you're -1, 0, 1, 2, 3, 4. Now if I take 4 and I subtract a negative 6, that's 10. If I take 10 divided by 2, that's 5. That should be the distance from the center point to each one of these vertices. 1, 2, 3, 4, 5. 2, 3, 4, 5. So that just gives me confidence that that's right. And you know, the green point is just inside. It's 4.6. So if this goes all the way out to 4, then this is 3, then this should be 3.6. Likewise, if this is 1, negative 1, negative 2, negative 3, negative 4, negative 5, this is going to be somewhere between negative 5 and negative 6, so it's going to be negative 5.6. And again, if you take 3.6 subtracted a negative 5.6, that's 9.2. If you take 9.2 divided by 2, that's 4.6, which is C. So again, feel pretty good about that. So that's what I'm expecting to do. So let's kind of just review what we did there. Take the equation, complete the square, get in standard form where everything equals 1. Simplify the denominators if you can do that. Once you have A and B, you can find C. Once you have A, B, and C, and H and K, you can get plot. Plot the center point, because the x-axis is the larger denominator, that's the major axis. And so you go from the center and count A units both ways. Go from the center, go up and down, B units. The focal point should be inside the vertices, so that's because you're taking A squared minus B squared, so it's always going to be less. C is always going to be less than A. So then you go from the center and count that distance to put your vertices in. Once you've plotted it, you can go back and figure out the coordinates of these points by just looking at where you put the dots accurately, hopefully, on the graph. I mean, there are special formulas. You know, this is H and this is K, and this would be K and this would be K. All these would have the same K. So you get that from the center. And this would be H minus A, and this would be H plus A. And these all depend, you know, if it has a major axis in the x direction, then you have this form. If you have major axis in the y direction, then everything would be H, and then you'd have K plus or minus A here. So here we'd have H minus C and H plus C. Now they didn't ask for the coordinates of the minor axis, but you still need that to draw the box. So that is it.